So let's continue with our next performance rock star here, which is Twan Koot.
Cool. Well, so thank you everybody for joining. We had some minor difficulties, which also can be expected when dealing with autoscaling. So let's start with a small agenda. First of all, we'll do small introductions of myself. I will talk about what is scaling, how can we scale, talk a little bit about test approach, your test goals, and I will finish off with hopefully a small slide which helps you start into how can I autoscale or test autoscaling applications. So what is autoscaling? Oh, it's based on two words. The first is auto and scaling. Let's start with auto. For me, that's the automatic process of scaling. That can be either by set rules in an application or on the infrastructure, let's say AWS or Microsoft Azure. And scaling is increasing or decreasing, but increasing is the most commonly, and decreasing the size or count of servers / computing power used. So this can be more virtual machines, more application server, or more CPU power, or more memory. And combining those two, you get the automatic process of increasing or decreasing the size or count of your servers and computing power used. And the concept is really old, but it's really gaining popularity by platforms as AWS or Azure, by those platforms giving us the means and the features to easily implement autoscaling, and the same goes for Kubernetes, with the HPA, so the horizontal pod autoscaler. When we talk about autoscaling, there are two main types of scalings, and this is a third one, but these are the main topics in scaling, is vertical and horizontal. So the first being the vertical one, it's scaling in size. So imagine you have a virtual machine or application server which has 4 CPUs, so 4 CPU cores and 16 gigs of mem. So vertical scaling means that you may be decreasing to 2 CPUs and 8 gigs of RAM, or increasing to 8 cores and 46 gigs of RAM. And for horizontal scaling, it's increasing the count of servers. So maybe you have 1 container and you're increasing it to 2, 4, 5, you name it. And the same goes for databases, database servers, application servers. You can increase the amount of servers you have which are serving the application you're hosting or testing. Some examples I already mentioned, increasing the VM size or server size. And we all know this beautiful screenshots from the Azure sizing table. This is a perfect example of scaling. And auto-scaling means that switching between these sizes is done automatically by certain triggers on metrics or time. It's also platform as a service or application as a service is Amazon RDS instances. If you increase the power, you're also scaling. And the same goes for decreasing your Docker container CPU limit. That's an example of vertical scaling. Horizontal scaling, it's quite easy. It's increasing the amount of servers. For instance, I already mentioned it, the Kubernetes HPA, the horizontal pod autoscaler. The name fits it correctly. And an AWS autoscale group is an example of horizontal scaling. There's also, I mentioned there are 2 main scaling methods, but there's also a third, which is scheduled autoscaling. And that's having a fixed time or dates on which your infrastructure scales in or out, so increasing in size or decreasing in size, which is really handy when you have a Black Friday sales promotion. You want to increase your service right before the promotion and decrease it after that happens, so you can handle the increased load during such times. But also, like many companies, nobody works at night times. Well, maybe during COVID, people working from home, it's a little bit changed. But in general, most of the companies don't have any activity during the night, so the servers are idling while everybody is sleeping. So that's a good moment to scale down your infrastructure, which again is really beneficial for the costs. And Henrik already mentioned it, but I will come to that later. And the same goes for in the weekend. Most companies don't have any activity, but it can be the other way around when you have a website or an organization which fully works in the weekend. You can scale up during the Saturdays and Sunday and scale down Monday to Friday. So this is an example or scheduled autoscaling, which you can use by asking around, okay, what's the typical use of our application? When do people work? Or when do we have a new promotion coming up? To talk to the marketing department, well, guys, girls, do you have any big promotions planned we need to know about, so we can schedule the autoscaling? Well, what are the benefits of autoscaling? Well, first of all, it's reducing unused capacity, which on a cloud platform decreases your costs. So when you are using more computing power or EC2 instances, so does your cost. So increasing autoscaling, or if you scale up, the infrastructure costs go up, and if you scale down, your costs are going down. So that's one of the main reasons why you want to use autoscaling, is to decrease the costs of your infrastructure. But it's also a great feature to have the flexibility to handle unexpected load spikes, for instance, during Black Friday, but also during normal day-to-day traffic. It's a great way to ensure you always have the right performance for your application. Because when it's starting to get a little bit busy on the system or on your application, you're able to scale up in VM size or pods or containers to handle that load and still deliver the right amount of performance for your clients and end users. But where there are benefits, there's also drawbacks. So let's go first to that. Scaling may cause more issues. When saying so, well, when we have a performance issue, just throw more CPU power at it. That's not always the case. It may be that if you add an extra server to your application server or front-end servers, it may start giving strange errors because of stateful, because you're having a stateful application. Autoscaling also requires a lot of performance testing, because you need to fine-tune the way you're autoscaling, on which metrics you're going to scale. Again, setting up the right metrics for scaling out and in can be tricky. If we go back, I always say cloud is as infinite as your budget. When your money is up, as your Amazon, Google says, well, no more computing power for you. So decreasing cost by implementing autoscaling can be really beneficial for any organizations. And this is again a really old example. 2014, they're already looking at scaling and decreasing the energy used in a data center. So it's nothing new, autoscaling, but it's more and more common because companies are looking and organizations are looking at their infrastructure costs and want to, of course, cut down on that, and especially during a pandemic, decrease in economic value. It's one of the first things people are looking at. Well, how can we decrease costs? Well, autoscaling can help you. But why do we need to test autoscaling? Well, when we do a normal performance test, when the developers or the Scrum team is delivering a new feature or code changes, we say, well, we need to test that because we need to know what's the impact on the end user. Does this new feature or new change has any impact, maybe positive or negative, on the performance? And the same goes with autoscaling. Autoscaling will change the infrastructure of an application. Just, of course, we need to test that because it's maybe increasing bottlenecks, it's revealing any new bottlenecks, it may be decreasing performance, it may be blowing up the infrastructure costs, or it may be cutting on costs. So it's really, you need to test autoscaling. Without it, it's really strange. Would you put a new feature into production without even testing it? No, you wouldn't do that. So the same goes for autoscaling. And I always say that's the number one reason for me is scaling won't fix bad designs or bad code. If you have a shitty application, it will perform shitty when applying autoscaling. So first of all, start load testing the application, fix any issues, make sure there's a healthy and efficient code base on which you can apply autoscaling. I once had a manager said to me, well, we have high performance, high response times. Could you just fix it by buying more Intel? That was the exact thing he said to me. And I was like, well, I really want to punch the guy, but I don't do it. But I said, well, that's never the issue. And the same goes for autoscaling. It's no fix for high response times. It's a feature to help you reduce costs and also to ensure performance for your end users or application. When we do autoscaling, we are changing components in our infrastructure. And by changing infrastructure or components, so does the baseline of your performance. Right? If you have one front-end server, an application server, and a database server, you have a certain amount of performance, capacity to serve to your clients. When you are changing your database server from 1 to 5, I give a random number, so does your performance. Maybe it becomes way faster or it becomes way slower. So you need to test every scenario in your autoscaling, from the minimum situation until the maximum situation, and everything in between. And you want to do this because you want to know the baseline of performance on each step in the scaling of your infrastructure. It's a great bass player. It's Flea from the Red Hot Chili Peppers, if you were wondering. So what are the testing goals for scaling performance tests? First of all, we need to scale, or we need to test for the minimal size, the desired size, the maximum size, and scaling out and in, and the metrics we need to monitor. The minimum size is the state of the infrastructure during nighttime, where there's no big activities on the server or on the application, maybe a couple of users which are logging in, looking into some stuff. That's the minimal size, and that's a load test with a really small load suitable for that type of infrastructure. Your desired size is maybe during the day where the load is normal, so all the people are logging in and doing their day-to-day work. That's a scenario for a desired size, so your typical load test would be sufficient for that. And your maximum size is those moments in the year where it's really busy, it's high traffic, so that looks like something out of a stress test scenario. And scaling out and in is switching between minimal, desired, and maximum, and going up and down. And during those tests, you also want to monitor the metrics. Think about CPU memory, because those can help you figure out when you need to scale up or scale down. And all these fit into your autoscale plan and settings in AWS or Azure or Google Cloud, whatever. So I talked about metrics. We also, every performance engineer and tester knows these metrics, but these can all be used to scale up and down. So you can scale up based on hardware metrics. So say the CPU is at a usage of 80%, then you say, well, we need to scale up in VM sizes, or we need to add an extra server. You can also scale up based on performance metrics, response times. If the response times start degrading to, let's say, 5 seconds, we need to scale up or we need to scale down. It can be anything. And it can also be done on user metrics. For instance, active users, if you start seeing more and more sessions on the server, you say, well, at 500 active users, we need to scale up our infrastructure to serve all the end users in the application. And again, you can have a Black Friday campaign, and then we need to scale up. That's also a metric for me. So when defining test scenarios for your load test for autoscaling, I can come up with 4. The first 3 are pretty easy. It's the testing for the minimum size, for the desired capacity, and for your maximum size. And the last one being the testing for scaling out and in, so scaling up and down in infrastructure. First three, you can combine those into one test scenario, or you can do it in separate ones. So if you look at this graph, the black line is your load, and you see it going a little bit up. That's your testing during minimum size. So with a small load, maybe 10% of the users, then you go to your desired size, which maybe is your day-to-day load, again, maybe 100% of the users, and your maximum size, and the load is increasing by twofold to your stress test scenario. And again, that scenario can be run in one test, or you can have a separate load test for each one of these scenarios. And the scaling in between these sizes can be done manually, because you're still figuring out what you'd want to do with autoscaling, or you can do it on set times during testing. So if you go back, maybe you know that you're scaling up in load from minimum to desired. After 1 hour of testing, you can also scale the system up from minimum to desired after 1 hour. Same goes for maximum size. These tests give you a lot of information about this last one, and the big test is the full-on autoscaling test, because the first three scenarios give you a lot of information about the key metrics on which you want to scale out, maybe on CPU or response times, and the performance levels associated with each of these sizes. So combining that information, you can set up your autoscaling. And if you have set up your autoscaling, you can set up your load scenario, which for me looks a little bit like this. Oh, this one. So this is a load plan I use for scaling scenarios. So the black line again is the load, for instance, in new load you set up. So you first start by putting a small amount of load on the system, and then you expect, okay, during that load, the infrastructure is at its minimum size. Then you start increasing the load, so it's scaling out to the desired size. Then again, you have a small plateau and you're going up in load. Then you expect the system to go to its maximum size. And then you start scaling in or scaling down into your desired size and your minimum size. And for me, autoscaling is all about going up and down and moving up and down. So you need to test scaling up and you need to test scaling down. Only testing scaling up, it's like 50% of the job done. So you need to also have a scenario where you are trying to test scaling down your system, because that's also something what will happen in production and what will start saving you those infrastructure costs. So it's really important that you also incorporate scaling down in your load test when testing for autoscaling. So how do you analyze autoscaling tests? Well, first of all, you compare your performance. So you start looking at, okay, does the desired scenario has the right amount of response time? How's the infrastructure being used? So CPU levels, memory, you name it. But you're also comparing scaling up and down with the expected moments during testing. So if you go back to this graph, when your test is done, you can look at the metrics in AWS or Azure and see when does the system scale up and down, and does it match with the expectations I had during my testing. If there's a mismatch between those expectations and the metrics in your platform, well, there's maybe a missing metric on which we can scale up and we scale down. So that's interesting to look into that. Okay, what's causing that we are not scaling up or not scaling down on the moments we expect during the tests? Secondly, you can also compare performance of each size with the load test you did way in the beginning before autoscaling, and look if there's a big difference in performance and what's causing that. And during scaling, look for anomalies like dropped sessions or increased error rate and even spikes in response times. Because when a server is scaling up, so there's a extra machine or computing power added to your infrastructure, it can happen, or most of the time what I've seen is that it increases response time for a small amount of time, and then it starts decreasing. Because a server is being started up, the software needs to be loaded in, and then it takes a couple of seconds, maybe minutes, to be all up and running. But in the meantime, the system is being hit with high traffic. So look into that. Maybe you can smooth the transitions by scaling up earlier or scaling down later. First, determine the possible scaling scenario possibilities. How can I scale on my application? Can I do horizontal, vertical, or only scheduled? Do a load test on the application to ensure that it's top notch. So the design is good, the code is really efficient, there aren't any obvious bottlenecks which need to be fixed before applying autoscaling. Then you can determine, okay, what's my minimal desired and maximum size in infrastructure. You can run a load test on each of these sizes, using one or separate, that's up to you. After these tests, you have the results of those three sizes. Then you can determine the key metrics on which scaling can be triggered. So it can be either CPU usage or response times. Now, those informations and settings can be put in an autoscaling plan. Then you can run the big test where you are going to scale up and down during your performance test by increasing the load and decreasing the load again. And then you can analyze the results, adjust your scaling plan or settings, and rerun the tests if needed. And yeah, this is for me the way I tackle autoscaling systems at clients when I need to test them, but also when a client asks, okay, well, can you help us by setting up autoscaling? I run this scenario to ensure I have the right setup and everything is performing as I want it to be. So are there any questions for the Q&A? Back to Henrik.
Thank you, Twan, for your presentation. I'm going to invite the various pack members to be part of the Q&A. I see that Stefano is connected, so I'm going to enable his webcam. Andreas is also connected, so I'm going to enable him. And Stain was connected, but I don't know if he still is there or not. But it doesn't seem so, so I'm going to disable his. All right. So first, before we ask the other pack members, there's two questions from the audience that I'd like to ask. Then we can I'm going to ask Stefano and Andreas if they have any questions. So, Tara, first question is, can you elaborate on how to go on testing scaling down test? As someone can question why it is required, except then more infra costs could incur for that brief time, but can it also affect performance?
So yeah, for sure, scaling down can affect performance because if you have, let's say, 4 database instances, and you're going back down to 1, it will affect your performance. And again, you want to go back down to your minimal state as soon as possible because you're decreasing costs and you're running efficiently. So that's, yeah, for me, it's how you want to do that.
Got it. There's another question, and then I have one question as well. Did you encounter a situation when autoscaling in/out doesn't work as expected? For example, new instance didn't get added when required, and so on. what approach can be taken to identify what's going wrong in such cases?
No, we had with the first release of AWS Lambdas functions, and we used that a lot to scale up and down. And what we would see is that it would take up to 5 minutes to have the function be able to handle load and deliver the right performance. And you would see that instantly in your response times or in your metric on usage. So it could happen, for instance.
It's exactly like you said, a stairway. So when you do the ramp up, you have a stairway happening. And then when you stairway, and then suddenly you have tons of errors.
Yeah,
the cloud trying to scale, so he spin up the instance, or spin it, but the node is not there to serve. It's there somewhere, but it's not there. So this is how you can detect those issues, I guess.
Yeah, you can match up the times of spinning up an instance and it being ready to serve clients or applications.
And what about, so you mentioned mainly, the cloud autoscaling stuff, but you can also autoscale on Kubernetes.
Yeah, for sure.
So what I try to recommend sometimes, say, why don't you take the number of pods that has been running during your component level, unit level testing. That could be a KPI to track between releases. If you one release you were consuming pods, and then I don't know, the next release you're consuming tens of pods, maybe there is something wrong. But yes,
sure.
Yeah, because it's a thing with Kubernetes environment. If you're over consuming pods, then you can assume that you will over consume resources as well.
Yeah, for sure. And you get pretty angry platform engineers who say we use too much of our pods. I've seen that, but yeah, it's a good metric for teams to look into. Okay, how many pods I'm consuming during testing or during development, and the same goes for cloud usage.
Yes, that's true. In fact, most of the APM product it can give you the number of nodes that are being available for a specific service, so you can track that. And you can also do the same with CloudWatch. CloudWatch provide that type of information, so you can try to track that.
I'm a huge advocate of enabling teams to also be make them more aware of the cost. So if give them metric, so maybe a team is responsible for the amount of infrastructure cost which is being used. So there's also a goal to work on.
Yeah, I think it makes sense. I mean, the people always say performance is equal response times, or sort of, but performance now these days with the cloud is also the cost.
It's all about the money.
Yeah, agree. There's another question that just came up in the chat, in the Q&A. So how do you tackle any performance issues when autoscaling is performed? How do you compare the in versus out, ramp up versus ramp down timings?
Yeah, so first try to identify the issue if it's based on bad code. So start at the basics, go back, stop the autoscaling, do a performance test on just a static environment, and find any issues which may be causing the issues. Because for me, what I have seen is that autoscaling amplifies any issues in code or infrastructure. So it's not hiding anything. It's amplifying. It's exploding any issues. So the first step for me would be just run a performance test on a static environment without any scaling, and check how's the application behaving and where can we optimize.
Yeah.
Because autoscaling adds a whole lot of complexity to the system. And it should only be applied on applications which are built correctly. It's a bit of an open door, but yeah.
All right. Stefano, how are you, by the way? Do you have any questions?
I'm great, thanks. Hi, everybody. Hi, Eric. How are you?
I'm very, so far so good. By the way, it's been 14 hours and almost 10 minutes.
Almost 10 minutes.
So
Still going strong.
Yeah, we are less than 10 hours to go, so it's almost nothing.
Okay. So actually, I had two questions. So by the way, thanks a lot, Twan, for the great presentation. So one question was is something on which we work a lot. Also, is related to the fact. So you're talking about the autoscaling. One piece of that we see is how do we select the best size for the autoscaling unit. So we are talking about Kubernetes before. So what is the process that you use to identify the best size for the pod template, for example? Here we have lots of trade-off. For example, many small pods or fewer bigger pods. There are lots of also implication in terms of resource utilization in the Kubernetes world, where we have, for example, sidecars, containers that are injected for each pod. So how do you go about solving this problem?
What I usually do is look how does the usage scale with increasing the load. So if you see a huge spike when you do a small amount of change in the load, okay, maybe it's better to have more of a bigger size for the pods. And if you see it's changing a little bit, then it's more of a capacity issue. And then you say, well, we need more. We need to scale more vertically or horizontally, or the other way around. We need to scale horizontally instead of vertically. That's what I tend to use. But again, it's really up to what kind of technology you are using. But in general, my go-to rule is to check, okay, how much is the resource increasing when I change the load a little bit. So it's increasing quite dramatically, maybe it's better to start with a bigger pod size or something.
Okay, cool. Actually, we have some similar findings. For example, we work a lot, as you may guess, with Java applications. So, for example, the JVM itself is not a kind of small runtime today. So actually, it may not scale linearly. So actually, you may have a pretty interesting overhead even with small amount of load. And there was also an interesting study that was done by Google SRE's team that we shared in a recent newsletter also. That actually studying this kind of relationship, they found out that some kind of sizes were more efficient than others due to the lack of linear scalability that is, of course, is not there. So it's worth exploring also the size of the unit of the scaling, because you may save some costs or increase the performance by selecting the proper amount of resources. Yeah. The other thing that we see some customers struggling is about the speed of scaling. I guess it was also touched a little bit before. So I don't know if in your experience, did you find any issue about the fact that containers are not being created fast enough, or at least the performance, the end-to-end performance is not so quickly on par with the rest of the instances?
So the main issue I mostly saw is that the scaling happens too slow. So that and the only way to fix that is to scale up or scale out earlier.
Earlier. So you work on the threshold and you make them happen sooner.
So there are a few big names of the industry who is mixing auto-scaling and also manual provisioning. For example, we know that, if I'm referring to a large streaming platform that has more than millions of users, they are provisioning automatically lots of instances during their peak hours, because they know that they need. So basically, they know that auto-scaling won't do the job, so they know that they need 100 servers that they're going to spin it up because they will load. So I think a mix of manual and auto could be a good solution.
That's a good example of scheduled autoscaling, because they know it's going to be really busy, so they already said, well, we scale up a little bit.
Yeah.
So
that's address the spikes.
Yeah.
Andreas, do you have any questions?
Yeah, one. I was wondering, how good does autoscaling work with databases? So like when you scale up, when you add one more node, the data needs to be shifted, or like a part of the data will be shifted to the new node so that it also has some node to process requests.
Yeah.
And during the shifting, it produces more load on both databases and also traffic. So what is your experience with it?
Yeah, what you usually see is just increasing on a vertical level. So it's increasing in computing power. And because there are some database engines which do support that type of scaling, but your more typical SQL and don't support that. So you need to just scale out in performance. So maybe add a bigger instance.
Okay.
But it's also up.
Sorry, go ahead.
Yeah, it's also up to the platform. So because there's a difference between AWS or an Azure, which types of scaling you have for those products.
And one other question: how quickly can you spin up a new virtual machine on Amazon, for example? Like how long does it take until it can process requests on an average?
It usually takes minimal. What I've seen, if maybe a minute. For me, that's
okay.
What I've seen. But if you use Kubernetes, it can be a couple of seconds. Then there's something ready.
Yeah.
Maybe Hendrik has more experience, figures on that, but
no.
Can you hear me, by the way?
Yeah,
we can hear. Oh, yes.
Yeah, sorry, I had some network issues. By the way, if I may add on this, it's also one of the things is that it's not just the time to boot the VM or actually spawn a new container, which is much faster. There's also some time spent in the runtime itself. For example, in a Java virtual machine it may take minutes actually to ramp up to the full speed due to the initial compilation, just-in-time compilation that the JVM and other similar languages needs to do. I remember one of the study that the same company that Henrik was mentioning before, a very famous streaming company, they studied a Java-based microservice, and they figure out that it took quite a couple of minutes, like 15 minutes or so, up to an hour actually to reach the full speed, so that the JVM really compiles all the hot code and really provide the fastest possible performance on par with the other kind of instances. So that's another kind of issues. Of course, there's a lot of work also on the JVM to improve on this, but it's another time that we should keep into consideration.
And there are also well-known coding frameworks in Java. Spring Boot framework is a great framework, but it's not the fastest one to load. So even if you pin up a new instance and you have to wait that Spring Boot officially has started and make the service available. So yeah, it depends of the framework that you choose as well.
Yeah, really.
There's
from
James Poulet, and that makes sense. So I have suggestions to invite him and interact lively, but so I'm going to ask the questions. So what about the concept of loose connectivity in horizontal scaling? For example, using queues for passing data between tiers instead of a hard connection. It would seem that is allow for easier integration of consumers and producers for the queues.
Yeah, of course, it's what I'm referring to microservices. This is what's starting the autoscaling hype, because it's way easier to do autoscale on those types of systems. So I agree, it's way easier to implement horizontal scaling on a stateless application, because it's stateless, so you can just autoscale whatever you want, and there's no issues with hard connections or user sessions.
And one small note from my part. What about combining chaos engineering in those tests? For example, if you know that the scaling rules will be based on CPU conceptions or whatever, what about, I don't know, making a CPU attack to make some consume more cores and force the cloud solution to scale? Would that be also a solution to testing?
For sure. You just test the settings for your autoscaling, and if you use a load platform like Neotys or Gmeter, or you use a chaos engineering tool, yeah, it's the same. You're triggering what you are testing, so that's good for me. But
all right.
To go. So if you have any other questions, it's the last moment.
So I'm looking at, we have 10 minutes before the next session. I think we have no other questions. Andreas, questions?
Good, thanks.
Yeah, it's really good for having me, and it was really a blast to have the presentation.
Yeah, thanks, Twan, again for your presentation.
Yeah.
Be again part of the pack, and that was a great topic to share. It makes 30 cents.